Right, does this thing work? Yep. Okay. So thanks everyone. Thanks for having me. Yeah, I'm on vacation here in London. It's been great. Taking a little break to talk about some GraphQL. Always fun. First of all, great talk. That was awesome. Especially the thing on the business logic not leaking in the API layer has been so important to me too. And at GitHub, we try to do our best, and we have been having trouble. And I think a configuration-based approach like this is just wonderful. Yeah, it's a great talk. We're going to switch over to some caching talk here. And caching and GraphQL together have been quite a heated subject. If you've been kind of looking at GraphQL as a technology, talking about it with people, you usually have like one person saying like, but what about caching, or doing some snarky comment. So a bit about me. My name is Mark. I work at GitHub on the API team called the Ecosystem API team. Previously, I was at Shopify too on a very similar team called API Patterns. So I've had the chance to play with GraphQL in production at 2 places for now. So it's been a cool ride. I come from Montreal, Canada. I work from home there. So GraphQL and caching. What's so passionate about this subject that we hear things like, oh, GraphQL breaks caching, or GraphQL is not cacheable at all, don't use it. It always sounded weird to me when I heard these sentences, or the people on Twitter, these tweets I would see, and I was trying to understand what people meant by that. Because to me, there's nothing inherent about GraphQL that wouldn't allow us to cache. So I started really thinking more about this, because I had so many people telling me comments like this, and I had to come back to them, trying to make them understand our context and things like that. So I decided to try to deep into that subject and try to understand all the little nuances. So even just caching itself is quite a broad subject, right? There's so many ways to cache, and it depends on so many things. So one thing I started thinking is like, is it true that really we can't cache anything server-side with GraphQL? And you discover pretty quickly that's not true at all, right? There's nothing about the GraphQL execution model itself that stops us from using caching. It's not written in the spec, you must not cache, right? And as an example here, that's Ruby code. Like if we have a name resolver for a GraphQL field here, nothing stops us from fetching something from a cache there. Surprising, right? So if it's not server-side, then when people say you can't cache GraphQL, it kind of has to be the client side, right? Well, not really either. If we look at the most popular clients out there, like Relay or Apollo, both of those initially had like really smart normalized caches that had like amazing features. It was kind of promoted even how like good their caches were on the client side. So it turns out when you dive a bit deeper and ask questions to people who kind of say caching can't be done, is that people are talking about HTTP caching. So okay, that makes sense. But to understand kind of why to say that, let's talk a bit about HTTP caching in general. So there's kind of 2 major concepts in HTTP caching. One of them is freshness, and the other one is validation. Freshness is a way for a server to tell a client, I'm giving you this resource, and you can keep it in cache. You can use it from a cache for this amount of time. So even if you want to ask it like 60 times, if it's within that time frame, just don't even ask for it, which is really useful. More precisely, with HTTP, it's usually done through a cache control response header, where we can set a max age like this. In that case, let's say you have an API client asking for API/user. The server would return this header, say, within 60 seconds, no need to fetch the server again, just use your local cache for this. The thing is, after these 60 seconds have passed, the client can now refetch again, because it assumes it's not fresh anymore. So we need a system for the server to say, well, you did good by asking again, but it actually hasn't changed. And that's what validation is. So avoiding to download a full resource again when the server can just tell you, well, you already have it. And there's 2 ways we can do that in HTTP. Most commonly used is a last modified header and the e-tag header. Last modified is, well, it's a timestamp of when that resource was last modified. And the e-tag is a little bit more interesting. It's kind of a token that tells you which state the object was. The client can then use one of these 2 values, depending on which one the server opted to use. If the server returned last modified, a client will usually use something like an if modified since header and tell the server, look, if the resource hasn't been modified, I don't want it, just return me nothing and tell me no content hasn't changed. With an e tag, we'll use something like if non-match, for example. So only return the resource to me if it hasn't changed and if it doesn't match basically that e tag the client had. And there's other cool thing you can do with that, like conflict handling. So only update this resource if it hasn't changed, for example, with other headers. It's really cool stuff for you. So you kind of understand why people don't want to lose this with GraphQL. So what actually stops us from using these things with GraphQL? If we think about it quickly, nothing really, right? It's just HTTP, and we can use GraphQL over HTTP. And there's a cool way to see GraphQL to me is kind of seeing them as client-generated server-side resources. So instead of telling your API team to, oh, I want this new endpoint, well, your clients can actually kind of tell you, send you a query, and that's my resource. And if you think about persisted queries, or I think stored operations at Twitter they just talk about, they're basically exactly that, right? We're creating a new resource and then consuming that resource after. So what if we could use cache control headers like this? Nothing's really stopping us, right? We say this resource here you created, the fetching friend's name on the current viewer, well, this can stays fresh for 60 seconds. The issue here is that since GraphQL queries are often so variable and different clients use different variations of the kind of same use cases, it can change, and the cache control header will change depending on every single field. So maybe the events field here actually changes a lot. So we must kind of return a smaller time frame for the whole query, even though we could cache friends longer. We could even use validation, right? We could compute a last modified for this resource, where maybe in that case, the same thing, maybe events change more often. So our events field is going to drive that last modified header more, and it's going to change more often. Same thing with an e tag, right? The problem with these is that they're usually quite hard to compute on the server side. To compute an e tag for a whole resource like this, or a last modified header, we actually need kind of to resolve the whole query and look at these objects and see if they've changed or not, which is almost the equivalent often than running the full query. We're just kind of saving the client from downloading the whole payload. So that's why you don't see it, even in a REST API world or HTTP API world, these e-tag solutions and last modified solutions are not kind of magic bullet. They still, on the server side, they cost as much as executing a normal request, except for the client, it's nice because you don't need to download it. Saves you some kind of bandwidth. So what we seem to realize with the example I showed where you add events and now it's recomputed more often, so it's kind of less cacheable, it's not really a GraphQL versus REST or GraphQL versus HTTP thing at all. This whole debate should not be about whether you should use GraphQL or not. It's more of a customization, variability versus optimization. And that's kind of a spectrum where even a REST API can be very customizable or very optimized. So I'm kind of tired of hearing about like that whole GraphQL versus REST thing, when actually there are some APIs there that are not GraphQL and they're not cacheable at all because of some choices they made. For example, you've got OData here that allows you to expand some fields, filter on some fields. That's actually really hard to cache for an HTTP cache too, right? Any filter you add here or any other resource you decide to expand would kind of dilute your cache and make it less effective. JSON API specification lets you kind of do GraphQL on certain resources. At some point, if you go even deeper, you're basically reinventing GraphQL. If you look at the Facebook Graph API, it's kind of like you see they were kind of migrating towards an approach like this. And even HAL, or I don't know if you pronounce it HAL, is a specification for hypermedia where you can embed some REST links directly in your resource. And the more you embed in your resource, the less optimized for one resource you are, the less easy it is to cache things, because any of these things may change, and you kind of need the client to refetch again. GraphQL chose to be very far on a spectrum. And like we heard in the last talk, we got to be aware of these trade-offs, but it doesn't necessarily mean that we can't cache anything. It just means we chose that very nice customization that we like, the fact that every client gets exactly what they want. but we gave away kind of that optimized thing where we can cache one resource for everyone. But it doesn't mean we can't cache, and doesn't mean we couldn't use HTTP caching either. The problem one that you'll hear a lot, and is kind of another misconception, is that people think you got to use post, the post verb, which is not cacheable, with GraphQL queries. And that's not exactly true, right? There's nothing in the spec that says you got to use post. In fact, it doesn't care about the transport at all. So we could say that our queries will be ran with a get verb, and our mutations will be ran with a post verb. In theory, there's nothing that stops us from writing our servers that way. If you try to run a mutation with a get, you could get an error status code with method not handled. So it's totally fine. The second problem that we hit with the get is that some servers, most servers, actually have query parameters size limits, and our GraphQL queries can get very large. That limit is not actually in the HTTP spec at all, but it's every vendor or service solution or even browsers have their own limits. So there's a few things we can do here. The first one is persistent queries we talked about. We don't want to actually be transporting huge queries every time. So what if we posted these queries to an endpoint that created one of these dynamic resources we talked about that GraphQL enables to do, and then instead of using the same query again, well, we refer it by its resource ID, right? And we get back that data. So that means we can easily do HTTP caching with that because it's just a resource, right? Here's another crazy idea. There's this weird request header called HTTP method override, where you can tell a server, listen, I'm posting this, but actually interpret it just that it was a get. So we could start posting GraphQL queries and say, actually, this is a get, and servers would cache it that way. It's kind of really weird. I wouldn't try it just yet, but it's a crazy idea. So it was kind of look like this. You post a GraphQL API, and you pass that method override get to say you're actually making a query, and that the server and the caches, even the shared caches, can be updated using caches. The other thing we hear about all the time is like, what about CDNs, shared caches, or intermediary caches? Like, how that's going to work with GraphQL? And while it's true that CDNs can be incredibly useful for like data that doesn't change too much and getting it closer to clients, there's a thing in the HTTP caching spec itself that says you can't store anything if there's an authorization header, meaning it's an authenticated query or a request. And for most of us, it's often true, unless you're only dealing with public APIs with data that doesn't change often. Most commonly assets, sure, that's great. But if you're dealing with, for example, at GitHub, we deal with purely almost authenticated APIs, except a certain part. Well, shared caches are not even useful there. And this is something we kind of, when you see debates on Twitter or anywhere about caching in GraphQL, I think this is forgotten a lot, because from what I've seen, most of us are actually writing authenticated APIs with GraphQL with kind of dynamic data, where that kind of caching is less useful. But there's always ways we can do it ourselves, right? And that's kind of the trade-offs we're going to see here. There's the vendor's way of doing things, and then there's the conventions. GraphQL is a really cool idea that I think is not active anymore. If anybody knows if it is, let me know. But I think it's not active anymore. But it was a great idea of a GraphQL-aware CDN that doesn't use HTTP just kind of as a dumb pipe and actually understands your mutations. So could invalidate caches based on the mutations you do, cache certain fragments. So it's a really cool idea. But it's not the HTTP spec, which means it's less convenient to use with any HTTP client out there or server, which is why conventions are so useful. So does GraphQL actually break caching? Well, not really, but it might not be the best choice for unauthenticated, rarely changing data. I think we got to admit that, and it is the trade-off we're making, and not a big one if you're not even dealing with that kind of API. Which is why I think it's so important to talk about context and bring some nuance to some of these talks, because if you're wanting to build an API that serves images or JavaScript assets, well, probably don't bring a GraphQL API there, but I don't think anyone is, really. And GraphQL can use HTTP caching, but it does currently require extra work, right? We talked about this. Right now, if you would just drop an HTTP client, with most GraphQL servers, it would probably break. For example, status codes that are not 200 or 500 basically mean nothing to most GraphQL clients. The caching verbs, you can't just use post for every query. So there's some few tweaks we can do there, but it's not actually impossible. We just haven't focused on it. And as I said a bit earlier, most GraphQL implementations right now just use HTTP as it could be anything else, right? They don't actually use HTTP to its kind of full power. And it turns out the HTTP spec was written by some pretty smart people, and there's some really good ideas there. So I think we could do a better job of kind of using these things in the HTTP spec by modifying our servers a little bit and our clients. So what can we do to make this better? I think there's kind of always two sides on this. On one side, it's focusing on GraphQL only and saying we need some conventions. Because in this talk, I didn't focus on how to do caching specifically. There's the Apollo server, for example, that will let you add some cache hints, and that works, but that's Apollo server. There's FastQL, the CDN, GraphQL aware CDN. Well, that's just FastQL. So we're in a very vendor-oriented world right now in GraphQL where there are solutions being written to many of these problems, but they're not very reusable. And of course, I have the public API way of thinking because we're building a public API at GitHub, which means we expect a variety of different clients and not always be working in for example, an Apollo client calling an Apollo server. It's going to be very different types of clients. So conventions are kind of very important to us, which I think we could have something like a GraphQL HTTP specification that says, if you're using GraphQL over HTTP, this is the way you should do it. And a bit of how we talked about today, for example, gets, queries should use gets, mutations should be post, is an example of something that could be in a specification. If you do have an authenticated API with data that changes often, like we kind of do, maybe you're not even missing much, right? We're considering the trade-offs here. We want that customizability. We know we have a various base of clients that have different use cases, and we're ready to accept that we won't use caching because we know our data changes a lot. We would maybe use cache control with like a second or even less, which could be useful. But we know there's other ways, either by caching on the clients or in the server itself, the application side, where maybe HTTP caching maybe is not even giving us that much. So we got to consider trade-offs here. If you're building a hockey score or a football scoring system where there's not many goals and data doesn't change that much, well, does GraphQL give you that much of an advantage? Maybe not. I think you can't just jump on GraphQL because it's the new thing. It has very big trade-offs, and they're so big they let you do a lot on the customizability side, but it's not great for everything. That's it. I think if you can take anything from that talk, I think it's let's bring some nuance into these subjects, ask more questions. It's not always black or white with GraphQL. And I think we can either ask for some more conventions on the GraphQL spec side, or bring some more HTTP in GraphQL by adapting our clients and servers. Thanks.
Any questions for Marc? Hello.
Hi, yeah, I was sort of curious about the method override header, actually. I've got a few questions around that. Like, does GitHub support that as a header? And no?
No, so it's a very obscure header that's been mainly used for bad in the past to kind of circumvent firewall rules and stuff like that. So we don't actually use that at all. It's just something I stumbled upon a few weeks ago, and I thought it'd be kind of interesting if we ever want to support something like this.
I mean, yeah, because that would be so useful for so many use cases
Right.
I have with GraphQL. I mean, because when trying to shoehorn it into a REST situation where you're trying to fetch many resources by their IDs, if the IDs are long, you get into that situation of length. And
that's true. Yeah. Oh yeah, it's definitely interesting. But so far, I think the only examples I could find are very hackers that used it to do something bad. So yeah,
that's a shame.
Anyone else? Hi.
So you mentioned there was a slide that you had that sort of had friends and name, and then an events field that we said would like change frequently.
Right.
So what do you think? I imagine like something beneficial would be like subquery caching. So how do you imagine that?
Yeah, I think we're gonna like this is something I would see the GraphQL community build for sure. It would be incredibly useful, but it's very hard to translate to HTTP caching, just because we're operating with like full resources all the time and like one endpoint. But on the GraphQL side, like on the application side, I think it'd be awesome. And actually there's one of my friend who still works at Shopify. They've built something like this because they have one part of their schema that's kind of the storefront. So like the products the store has, which doesn't change often. Another part that's more like admin-like, where inventory can change. So they've annotated their schema. Some types can be cached and others not. And they kind of have a middle-of-the-road approach where if every field in the query is cacheable, they do full query caching. And if there's some fields that are cacheable or not, right now they just don't cache. But I can see that approach where you say, I'll select these types you've annotated on the server side as cacheable. We'll cache those, and then we'll pull those from cache and compute the other ones. I think it's a perfect approach, and that solves like kind of the problem where one field that maybe like the worst cacheable field, like current time or something, gets in a query and just breaks the rest of the query. It's a good point.
Just one more over here. It was the same question.
Hi. So as a disclaimer, I don't use GraphQL subscriptions at all.
Okay.
But I can see that they could negate the need for any server-side caching. In principle, with this idea that you're subscribing to changes to a query, therefore refetching should be very rare. Is that something that you've played with at all?
We've played with it a little bit. We're starting to play with it, and you're totally right. If in a world where you're just like reacting to events or even like live queries, caching has kind of a less value. I think the issue is that not every server is gonna support that. It's actually quite hard to build. So I think there's always going to have value of just dropping in an HTTP client that knows how to handle all these HTTP things, and the server knows how to respond to that, and there's no magic there, like no vendor-specific things you need to look for. You just drop an HTTP client and you can call a GraphQL API. You're totally right, though. If we in a world,
perfect world.
right? Yeah, in that world where every server has a fully fledged subscription schema or live queries annotations where you just get all updates, it's kind of less useful. Yeah.
Anybody else? Okay.
Yeah,
Thank you very
everyone.
much, Mark. Thank you, Anghel, and thank you, Twitter, as well.